In this video, we're going to discuss the concept of a learning curve and how it can help us with several questions, such as the question, how much data do we need? So let's have a look at the learning curve. A learning curve looks like this. On the y-axis of the learning curve, we have the performance. For this example, we use the error rate as performance measure. Remember, the lower the error, the better the performance. On the x-axis, we have the training set size. Usually, we plot both the test error and the training error together in one curve. So why would we look at this learning curve? Well, it can help us answer three questions. To start with, are we overfitting or underfitting? The more we are overfitting, the larger the gap between the train and the test error. The second question that we can answer is, how much data do we need? One way to estimate this is by extrapolating the learning curve. Here, I have linearly extrapolated the test error. This way, we can see how much more training data we approximately need to get a better performance. Finally, the third question is, which model should we use and in what case? The learning curve can also give us insight into this problem. For this, let us look at another example. This time we only look at the test errors and we look at two different models. Here we have our blue line, which represents a simple model, and a red line, which represents a complex model. For a simple and a complex model, the learning curves often cross. That is because a simple model usually doesn't need much data to train well. The training error rapidly decreases, but then it plateaus. The performance for this simple model is limited by the bias. At some point, it cannot improve its performance anymore. This is because the bias is always constant. For a simple model, usually the variance decreases rapidly. So that is why it converges faster, but then it cannot improve anymore. Now let's look at the more complex model. The complex model starts out worse because if the training set is small, it overfits a lot. So that is why initially the error is higher. But at a later point, this higher variance can be compensated by a larger training set. Therefore, at some point, the complex model can get a lower error. The complex model has a lower bias, and that is why it can get this lower error, if the variance is compensated by a larger training set. Usually, the simple model plateaus earlier than the complex model. That is why the curves cross. So, we see if we have little data, you should use a simple model. If you have a lot of data, you should use a complex model. Okay, let's summarize this video. What we just saw is we saw that there is no single best model. Which model is best depends strongly on the size of the training set. If we have a small training set, a simple model usually performs well. If we have a very large training set, a complex model can be even better. Finally, the learning curve can help us with several questions. We can see if we are overfitting by comparing the training and the test errors. By extrapolating the learning curve, we can see how much data we need to reach a particular test performance. Finally, the learning curves gives us some insight about selecting the right model. Using the learning curve, we can see if our model has converged. In that case, we can decide to switch to a more complex model.